So this topic is actually on, electrical power and energy. Correct? So are you on this topic, electricity as well, Toby?
Yes, I already learned some of it, but I haven't learned like power.
You know about power rating? Don't know. Okay. Do you know that electrical appliances has power rating?
Yes.
Okay, hold on. Electrical energy. Give me 1 minute. Now, okay. So let me share the screen and then let's go through the worksheet. While going through the worksheet, I will be also teaching you a little bit here and there about power. Now, there is actually certain things you need to know, about power, right? Electrical power. Now, it's not like the superpower that we are talking about. Okay. So it start off with SI unit for power. Are y'all seeing my slides? Okay, worksheet 21, you're looking at the correct slides, yeah? Now, so this electric power, when we talk about electric power, you can easily find a lot of resources online, okay? It tells us something, related to electrical energy. So it is actually the rate at which electrical energy is transferred. Okay, right. So how fast electrical energy is being transferred? Something that you need to know. The SI unit for power is actually watts. Okay, so just represented by a capital W. Right. So this watt, right, actually represents 1 joule per second. Okay. Then energy is actually measured in joules. Right. So these are the very brief thing we talk about. If you look at electrical appliances, let me see. Do I have anything I can show here? Okay, let me see. Power rating. Just some examples to show you. Okay. Is this a good one? Okay, so maybe I show you all this. Take a look here. All right. Hopefully you can see. I'm sharing my screen now. I just went to Google, power rating. Okay, so this is the brand Philips. Must be one of the gadget. I don't know what is this. It's not stated. Okay, but do you see some values here? Can you see 2000 watts? Correct? At 240 volts. Can you see that? So this 2000 watts shows power rating. Okay, Jocelyn, you're following. Nicole, Javier, can see this part or not? Yes, let me know. You must respond to me because in I turn on camera, I'll be worried whether you are with me or you fell asleep. Okay, so this is important. You respond to me so I know. Now, so power rating tells us something, how much electrical energy is being transferred. Then the power rating also tells us whether this particular gadget is going to consume a lot of electricity or not. Okay, so the higher the power rating, the more energy is going to be using. All right. So if you were to look at other gadgets, okay, you will also see different rating. I have one for a fan. This is interesting. Okay, so just explore a little bit together. I don't like to rush into the worksheets, just discuss a little. Can you see a fan here on the screen? So what's the power rating for the fan? Can you see 30 W, 30 watts? Yeah, so compared to just now, that one 2000, isn't it? Which one has a higher consumption of electricity? Is it the earlier one or the fan? Type in earlier or fan. Okay, Javier responded. The rest of you, what do you think? Which one will actually consume more electrical energy?
Can you repeat your question?
Okay, just now we saw the 2000 watts, right? Power rating. Then this fan is 30 watts in terms of power rating. Which one consumes more electricity? Which one will use up more electricity to operate? Earlier or fan?
The earlier one.
Earlier one. What about Jocelyn? What do you think? Is it earlier or the fan? First one, right? Yeah, Jocelyn said first one. Nicole, what do you think? Nicole, not sure. Nicole? Earlier, correct. Good. So good that you're roughly know lah. Then it is also something that we need to be aware of when we are buying a lot of electrical appliances. Okay, we need to also take note of the power rating, no? Otherwise, we might be using a lot of electricity at home. End of the month, when you get your electrical bills, you'll probably faint. Correct or not? Because you have to pay a lot for electricity that particular month. Quite scary, yeah? Okay, let's see. Yeah, so there are other examples. Maybe next time I can collate a list and show you, okay, power rating. So if you want to decrease, okay, the use of electricity, okay, you can go for those that are energy saving, okay, energy saving. So let's look at this particular definition of power and its SI unit. Okay, SI unit already is easy for us to recall, right? Okay, we know that it's actually watts, isn't it, for power? Okay, so we know that it's either this or this, right? So how do we actually talk about this now? Is it going to be rate of flow of charge, or is it going to be rate of energy conversion? Okay, how do we actually determine this? All right, so in order to actually understand, you need to know actually is the rate of energy conversion. So power is actually also defined as the rate of energy conversion. Just now we talk about energy transfer, right? Okay, it's actually a very general term, but if you are going to be more specific, it's energy conversion. Electrical energy converted into what form? If I'm talking about the lamp I have in front of me, okay, then it's actually light energy. Electrical energy is being converted to light energy. But with light also comes heat, isn't it? Okay, if I touch my lamp right at the top bar, then it's going to be warm. Okay, then how about our laptop? Okay, now I'm using one laptop in front of me. I have a screen on the right-hand side. Then I have my writing pad, okay, at the bottom. So all these consume electricity. If I want to look at my writing pad, okay, what is the power rating? I can see it also. Yeah, how much energy is actually being consumed because it's converted to light. Agree or not? Okay, so all this helps. So answer is actually C. Okay, rate of conversion of energy. Let's see your answer. I can also look at whether you got it right. Yeah, Toby, you actually chose A, huh? Okay, it's either A or C now, you understand? Yeah, okay, so it's a conversion. Javier got it right. Nicole A. Jocelyn, you never do the worksheet this time round. Jocelyn, what happened? Electricity made you cry. Oh dear. No, please don't cry. Yeah, with more practice, you can do this. With more practice, you can do this. Tell yourself that. Okay, I will try to make it easy for you lah. Can or not? Okay, so we go question by question, and then with every question, we can talk about certain information, science, content behind it. Can, Jocelyn? Look at these particular question. Okay, we want to find resistance of resistor R. Okay, resistor R, you can see right in A, B, C, D, they are all there, right? So how do we find resistance of R? Now, of course, if let's say is at home you want to measure resistance of a resistor R. So long as you have this gadget called a multimeter. Okay, if you have a multimeter, you can test. You can test, We also have our FET application, isn't it? Remember or not, the FET application where you can try to create your own circuit, then you can use the voltmeter inside to test out. So if I have FET, let me quickly just open this up. Okay. All right. So this application looks like this. Take a look. Okay, this application looks like this. Toby, are you familiar with this one? You are, right? Yeah. So there's a voltmeter, there's an ammeter. Okay. Yeah. So you can explore on your own. There are many functions here for you to try out. Okay. So in the science lab, you are supposed to know how to measure certain certain values, right? Okay, in order to calculate your resistance. Okay, now we use this formula, Ohm's law. All right. This formula from Ohm's law, where you have V, I, and R. This is the equation we use to calculate resistance. When we want to calculate resistance, okay, resistance is represented by letter R. We are going to use the values for V and I to calculate this. What is V? V is the number of volts, right? It's a potential difference. Okay. And then I is the current that's flowing in the circuit. Javier, you think you chose the wrong one, huh? Okay, not to worry, yeah. So you check on your own. Okay, let's see, Javier. Right. Okay, I understand what you mean. Okay, in fact, everyone who did this, okay, let's see. Javier, you chose. Yeah. If I ask you to change your answer now, Javier, what would you change it to? Yeah. You know how to connect to a voltmeter as well as the ammeter, right? Toby, do you know? Toby, do you recall how to connect? How do you connect ammeter?
In series.
In series, okay, in series with the component. What about the voltmeter?
In parallel with the
with the component you're measuring. Yeah, good. So answer here is definitely C, right? Okay, so the voltmeter helps you to measure potential difference across the resistor because we are now calculating resistance of resistor R. And therefore, if I connect the voltmeter across this way, I can find V. Okay, so V will be a certain value, and then ammeter connected in series, I'll be able to find the current. Then when I put in the values, it will eventually give me my answer in ohms. Clear about this? Okay, not too difficult, yeah? But if I have a question now, can you identify the positive terminal of the ammeter? Okay, so let's look at this option C's circuit, right? Ammeter. Where is the positive terminal? Top or bottom? Top here or bottom here? Okay, You all can type in the chat. Okay, yeah, all right. Somebody gave